Welcome to this deep dive, parents of Coego's Thursday programming students at OCSI. We're so glad you're here.
Yeah, it's fantastic to have you all join us. We know jumping into the world of code can sometimes feel a little like, entering the Matrix.
Right.
But trust me, you don't need to be Neo to appreciate what your kids are doing.
Exactly. Today's all about giving you a peek behind the curtain of Chapter 2 in the Nature of Code by Daniel Schiffman. It's the book that's, guiding your children's coding adventures this semester.
Right.
And don't worry, we're keeping it parent-friendly.
Yeah.
No coding experience required.
So think of it this way. Remember those early days when your kids were learning to walk?
Oh, yeah.
A step forward, a wobble back, a sudden dash to the left. That seemingly random exploration. It's a lot like what they're doing with code right now, actually, using something called a random walk to simulate movement.
Okay, a random walk. So they're basically teaching the computer to be as unpredictable as a toddler.
Pretty much, yeah. But here's the really cool part. They're not just letting the computer run wild. They're learning to harness that randomness using vectors.
Vectors. Now, I remember that word from high school math class.
Yeah.
It vaguely involved arrows.
Right.
But how does it apply to making things move on a screen?
So imagine you're giving your child directions, like take 3 steps forward, turn right, take 2 steps.
Okay.
Those instructions, those are like vectors. They tell you both the direction to move and how far. In code, vectors are essentially sets of instructions that tell a computer how to move something on the screen.
So when my kid's coding, a character running across the screen, they're using vectors to say, go 5 steps to the right, then jump up 2 steps.
You got it. And the tool they're using in the P5.js language, which is based on processing, to do that is something called pvector.
Yeah.
It's basically a shortcut command that lets them write those vector instructions more easily.
Pvector.
Got it.
So it's like a secret code word that makes moving things around a whole lot simpler.
Exactly. And right now in their lessons, some of your kids are taking those p-vectors and putting them inside something called a loop, which lets them repeat the same instructions over and over.
Ah, loops. So instead of writing move 1 step forward 100 times, they can use a loop to say, do this 100 times.
You're catching on quickly. That's precisely what a loop does. It's all about efficiency and making the code more elegant. And it's a foundational concept in programming.
Okay, so we've got our random walks, our vectors, and our loops. What else are they tackling in Chapter 2?
Well, now they're starting to play with forces, which, as you can imagine, is a pretty big deal when you're trying to simulate how things move in the real world.
Right, because things don't just zip around at random in real life. There's gravity, wind resistance, all that fun stuff.
Exactly. So in Chapter 2, they're learning how to apply those forces in their code. Think of it this way. They're not just choreographing the movements anymore. They're creating the physics of their little digital worlds.
That's pretty amazing when you think about it. They're basically playing God with their code, creating their own laws of physics.
Yeah, and that's where the nature of code really shines, I think. It helps them understand how the real world works by translating those principles into CAD. For instance, the book dives into Newton's laws of motion and how they can be applied to simulations.
Newton's laws, oh boy, flashback to high school physics class. Didn't those involve apples falling from trees and things like that?
I do, yeah, and it's more relatable than you might think. Take Newton's first law, the one that says an object at rest stays at rest, and an object in motion stays in motion unless acted upon by a force. It's kind of like getting your kids to do their homework sometimes.
Oh, yeah, I see what you mean.
They'd much rather stay at rest on the couch.
Okay, I see where you're going with that. So if we want to get that object or our child off the couch, we need to apply a force.
Exactly, yeah. And that force could be anything from a gentle nudge to a full-blown get your homework done or no video games decree.
Huh. Sounds like a force most parents are familiar with. But how does this tie back to the code the kids are writing?
Well, they're learning to translate those forces into their code. For instance, if they want to simulate a ball falling to the ground, they need to program in the force of gravity.
And what about things like wind resistance or friction? Are they coding those into?
Some of them are, yeah. Particularly those who are working on exercise 2.3 in the book, which challenges them to combine multiple forces in their simulations. For example, imagine a ball bouncing under the force of gravity while also experiencing air resistance.
So they're not just making a ball fall straight down. They're making it bounce and slow down realistically. That's pretty impressive.
It is, yeah. And it all builds on those foundational concepts of vectors and forces that we've been talking about.
So by understanding these basic principles, we can start to appreciate the complexity of what our kids are creating.
Exactly. And we can start to see the connections between the digital world they're building and the physical world we live in.
It's fascinating to think that these kids are not just learning to code, they're learning to think like physicists and engineers.
You're absolutely right. They're developing a deeper understanding of how the world works and how to manipulate it through code.
So it's not just about making cool animations or games, it's about fostering a whole new way of thinking.
Precisely. And that's what makes this journey so exciting. They're not just learning to code, they're learning to think creatively, solve problems, and express themselves in a whole new language.
It's like they're unlocking a secret superpower, the power to create and control their own little universes.
And the best part is, we get to witness their superpowers unfold. It's a privilege to be a part of their learning journey.
It really is. And for all the parents out there who are feeling a little lost in this world of code, remember, you don't need to be an expert to appreciate the magic of what your kids are doing. Just be curious, ask questions, and enjoy the ride.
Well said. And who knows, maybe you'll even discover a hidden coding talent within yourself along the way.
Now, that would be something, wouldn't it? But even if we don't become coding wizards ourselves, we can still be their biggest cheerleaders and supporters.
Absolutely. Because at the end of the day, the most important thing is to encourage their passion, their curiosity, and their desire to learn. And that's something we can all do regardless of our technical skills.
Well said.
So, all right, we've covered some of the basics, random walks, vectors, forces. Now let's talk about where all of this can lead, because what your children are learning in chapter 2, it's really just the foundation for some truly incredible things.
Okay. You've piqued my curiosity. What kind of truly incredible things are we talking about?
Think about this. Imagine your child creating a simulation where a flock of birds flies across the screen.
Okay.
Each bird moving individually, but also reacting to the movements of the others, almost like a real flock.
Wow, that would be amazing. How do they even begin to code something that complex?
Well, it all builds on those basic principles they're learning now. Later chapters of The Nature of Code introduce concepts like steering behaviors, which allow objects to make decisions about how to move based on their surroundings.
So instead of just following pre-programmed paths, the birds can actually react to each other and make decisions on the fly.
Exactly, yeah. It's like giving them a little bit of artificial intelligence. And then there are particle systems,
Okay.
which allow them to create effects like fireworks exploding or water flowing or even smoke billowing.
All those amazing visual effects we see in movies and video games, my kid could actually learn to create those.
Absolutely. And it all starts with those fundamental building blocks they're learning right now. Vectors help define the direction and speed of those particles. Forces influence how they interact with each other and their environment. And loops help manage all those calculations efficiently.
That's mind-blowing.
Yeah.
It's incredible to think that the things they're learning now can lead to such sophisticated creations.
And here's the really cool part. Even without being programmers yourselves, you can now start to see those concepts at play in your child's work.
So when I see my kid's latest coding project, I can actually point out the things we've been talking about.
Absolutely. You can say, hey, I see you're using vectors to make that character move, or that bouncing ball looks so realistic because you've coded in the force of gravity. You can have a real conversation about the thought process behind their creations.
That's fantastic. It's like we've been given a secret decoder ring to understand this whole new world.
And the best part is you can engage with their learning journey on a whole new level.
So how do we do that? What can we do to support our young coders beyond just understanding the concepts?
The most important thing is to be curious. Ask Ask them about their projects. You know, what are they working on? What challenges are they facing? What are they most excited about?
And I bet they'd love to show off what they've learned.
Exactly. Yeah. Encourage them to explain their code to you. You might not understand every detail, but you'll be amazed by their passion and how much they've absorbed.
Yeah.
You might even want to check out the Nature of Code website together.
Oh, okay.
There are tons of examples and exercises that you can try out as a family.
That's a great idea. It's like a new kind of family game night.
And who knows, maybe you'll even discover a hidden coding talent within yourself.
Well, I wouldn't bet on that. But I love the idea of learning and exploring this world together with my kids. It's a whole new adventure.
It is, yeah. And it's an adventure that's full of possibilities because the skills they're developing, they extend far beyond the realm of coding.
What do you mean? What other skills are they picking up along the way?
They're learning problem solving, logical thinking, creative expression. These are skills that are valuable in any field. It's not just about writing code. It's about developing a way of thinking, a way of approaching challenges that will serve them well, no matter what they choose to do in life.
So it's not just about creating video games or animations. It's about equipping them with tools and a mindset that will help them thrive in a world that's increasingly driven by technology.
Precisely. And it all starts with those fundamental concepts, those building blocks of motion and interaction that we've explored today.
Yeah, it is amazing to think about how much ground we've covered just talking about Chapter 2. It feels like we've only just scratched the surface of what's possible with code.
Oh, you're absolutely right. And what's truly exciting is to think about, where those coding journeys will lead in the years to come. I mean, they're starting with these basic elements, vectors, forces, loops, but the possibilities for combining and expanding upon them are practically limitless.
Yeah, it's like they've learned the alphabet and now they're starting to form words, then sentences, and then whole stories. Makes you wonder what kind of coding novels they'll be writing in a few years, right?
It really is incredible to think about the creative potential that's unlocked through coding. And this creativity isn't confined to the digital world either. The skills and the mindset that coding cultivates, problem solving, logical thinking, creative expression, those are transferable to just about any field.
So it's not just about, creating video games or animations. It's about developing a way of thinking, a way of approaching challenges that is valuable in any profession, any walk of life.
Precisely. And as parents, you're in a unique position to nurture that growth by encouraging their curiosity, engaging in conversations about their work, by simply being present and supportive. You're playing a vital role in shaping their future.
Sounds like we have a pretty important job. Any tips for those of us who aren't exactly coding whizzes ourselves?
Well, I'd say embrace the learning journey right alongside them. Who knows? You might even find yourself getting caught up in the excitement of coding and discovering a hidden talent. But even if you don't become a coding expert yourself, you can still be their biggest cheerleaders.
So ask questions, be supportive, and maybe try a coding tutorial or two. I can try that.
Exactly. Yeah. And as you watch your child's next coding project come to life, try to spot those concepts we've discussed, the vectors, the forces, the loops. It's a fun little challenge and a great way to connect with their world.
Well, to all the parents listening, thank you for joining us on this deep dive into the world of code. Remember, curiosity is key, support is essential, and the possibilities are truly endless. Keep exploring, keep learning, and keep creating alongside your incredible young coders.
And until next time, happy coding.